the purpose of this video is to learn how to write conversion factors. An example of a conversion factor might come into play. Let me get my drawing on here. If you were thinking about the amount of mercury that you get into tuna, right? So you'd be told that the maximum amount that the government allows for tuna to have, the maximum amount of mercury that government allows in tuna is 0.5 parts per million. So you might be asked, well, how much mercury is that, right? So the learning goal for this section is to write conversion factors for two units that describe the same quantity, and we are going to learn how to deal with numbers like that. Mercury in tuna, 0.5 parts per million. All right, so first of all, we're going to start out with equalities. So the concept of an equality is what you might imagine. Two different units that describe the same measured amount. For example, 1 meter is equal to 1,000 millimeters, right? That's an equality. And we also write equalities that are written between US units and metric units, okay? So, for example, 2.2 pounds giving 1 kilogram, right? So these are equalities, and you'll see that we can take equalities and we can turn them into conversion factors by putting one side of the equation on the top and one side on the bottom. And so any equality, for example, 60, it's right there, 60 minutes equals 1 hour can yield two possible conversion factors, right? Where 60 minutes is on top or 60 minutes is on bottom. These are both legitimate conversion factors. It sort of depends on what you want to do with them, right? But they're both legitimate because the top and the bottom are equal. And so both of these two ratios are equal to each other. And an example of a conversion factor for a metric unit would be if you take this equality, 1 meter is equal to 100 centimeters, right? Centimeter came down there. 1 meter is equal to 100 centimeters. Then that was one conversion factor, and here is another conversion factor that you get from that equality. All right, so the numbers in any equality between two metric units or between two US systems are obtained by definition, and therefore they're exact because there you get those by definition. That is, if it's between two metric, or between two US system units, they're exact, okay? A definition is exact, and they're not used to determine the number of sig figs, right? Now, an equality between a metric and a US unit contain one number that's measured by that's obtained by measurement, and the other that's not. So the one that's obtained by measurement does count toward the sig figs. It does count toward the sig figs, okay? And an important exception to that is as follows. The equality 1 inch is equal to 2.54 centimeters. That's considered to be a definition. That is in this case is determined or is considered to be exact. All right. I've got some slides in here I forgot to get rid of, so we're gonna skip past a couple of them here. Some common equalities, you've seen this a couple times. Some common equalities: 1 kilometer is equal to 1,000 meters. This is a table from your textbook, which you'll be given for all of your quizzes and exams. 2.54 centimeters is 1 inch. You're reminded here that it's exact. You see that there. 1 meter is equal to 39.4 inches, which is not exact. 1 kilometer is equal to 0.621 miles, which is not exact, right? That's because it's between metric and US. These are all exact because these are between metrics, and these are US to US, right? So these are exact, right? And these, since they're between the two different systems, are not exact with the important exception of the inches and centimeters. All right, so we've already said this. We can write metric conversion factors from any definition. So 1 meter is equal to 100 centimeters. Therefore, that's a decent conversion factor, and there's another decent conversion factor. All right. The conversion factors between US and metric, these now come from, from an equation, right? Here's a conversion factor, and here's a conversion factor that come from that equation. It turns out this is an exact number because it's just 1, but this has 3 sig figs in it. That is measured. All right, so let's do a learning check real quickly. Write conversion factors from the equality of each of the following: liters and milliliters. I'm going to rush it, but you should pause the video here and then come back and see and play. Come back and hit play and see what I say and compare your answers to mine. Okay, so I'm going to suppose that you paused it. A, 1 liter is equal to 1,000. Oh, we already have that. Yeah, well, actually, I should write out the equality first. 1 is equal to 1,000 milliliters. So a decent conversion factor would be 1 liter, 1,000 milliliters, or 1,000 milliliters equal 1 liter, right? Those are good conversion factors. Now let's look at B. B, meters and inches. 1 meter is equal to, I think, 39.4 inches. We'll go check that. 1 meter is equal to, there you go, right there. 1 meter is equal to 39.4 inches. That's what I've got. And so a good conversion factor would be a meter, 39.4 inches, or 39.4 inches in 1 meter, right? So those are good conversion factors. All right, so let's switch colors here. Good size marker, yep, okay. And let's do C. C, 1,000 meters is equal to 1 kilometer, right? And so 1 kilometer over 1,000 meters is a good conversion factor, or, and we just say the inverse of that. All right, so I'm going to skip past the solutions because we just did those. And let's come here now and look at conversion factors within problems. So inequality may also be stated within a problem that applies only to that problem. For example, if a car is traveling at a speed of 85 kilometers per hour, you can say 85 kilometers is equal to 1 hour in the situation of this problem, right? 1 kilometer is equal to 1 hour, right? And so you've got 2 conversion factors that can come from that. Another example might be the price of onions, $1.24 per pound. $1.24 is equal to 1 pound, right? Okay, so you can get 2 conversion factors from that as well, right? See what we're doing with that? Okay, so let's look at one in a dosage problem. Equalities stated within dosage problems for medications can also be written as conversion factors, right? So if you have a 250 milligram capsule, then 1 capsule equals 250 milligrams, right? And so there's a good conversion factor, and then the inverse of that is also a good conversion factor because 1 capsule has 250 milligrams in it, and 250 milligrams is equal to 1 capsule, right? So let's consider now percentages and parts per million and parts per billion. If suppose that you found out that you were dealing with a situation which you had 18% body fat by mass, that would mean that you had 18 kilograms of body fat for every 100 kilograms of body mass, right? And so there's a good conversion factor. 18 kilograms, can you see that's percentage? 18% means 18 kilograms of the part for 100 kilograms of the whole. And the part in this case is body fat, and the whole is body mass. All right, in parts per million, it operates under exactly the same principle. It would be 1 gram per a million grams, right, of the part to the whole, right? And a decent conversion factor would be the inverse of that. And billion would be the same thing. All right, so let's do a learning check here. Write the equality and its corresponding conversion factors. Identify each as exact. Give it sig figs, and give it sig figs in the following statement. Okay, 1.9% omega-3. So that's going to be, let me go back to red here, 1.9 grams of omega-3 acids per 100 grams, right, of salmon, right? And so this is exact because it's defined as 100 grams, but this is measured, and it has 2 sig figs in it. Okay, and I think that's all I'm going to do with that one. So let's wrap this up with a learning check. Write the equality and the conversion factors for each of the following. So first of all, A, meters and centimeters. 1 meter is equal to 100 centimeters. You should pause the video and do this real quickly. And then come back and compare your answers to mine. Okay, let me suppose you did that. And that is going to give you 100 centimeters. We've done this like this is our third time in this single presentation, or the opposite, right? Or the inverse, I should say. Okay, B, jewelry that contains 18% gold, that would be 18 grams of gold, which I'm going to write as AU, over 100 grams of jewelry, which I'm going to write as J. Okay? I didn't write the equality, but there's a good conversion factor, or the inverse of that. And let's come here. C, 1 gallon of gas is 340. 1 gallon, here's the equality. 1 gallon is 340, right? And a decent conversion factor is 1 gallon is 340, okay? Or the inverse of that. All right, so we've practiced we've practiced using equalities to make conversion factors, and we're going to use this a lot. Good luck.